I have already evaluated the Thermaltake Tough Power GF A3750 a while ago. Still, it seems Thermaltake silently changed the OEM for this line to CE Link from HKC to exploit the Vietnamese factory of this OEM, which leads to lower import fees in the US market. I cannot say that I particularly enjoy it when a brand changes OEMs without changing the product's name or providing some information on the box to help buyers distinguish the different versions. Since we are talking about completely different platforms, users should know which version they will get before they commit to buying these products. Compared to the Chinese GF80, this one has a 12V 2x6 connector, so it is ATX version 3.1 compliant, a lower cybernetics noise rating at 115V, cybernetics A versus A-, a different fan, and a maximum operating temperature for continuous load at 50 degrees Celsius versus 45 degrees. The efficiency rating and the dimensions remain the same. I would like to note here that the Chinese GF80 units probably got a silent upgrade of the 12+4 socket to 12V 2x6, but I cannot confirm that since I don't have any new review samples of them. The box is almost identical to the Chinese-made unit with the 80+ logo on its front side. Nonetheless, Thermaltake only sent the HKC version for certification, believing that nobody would notice the different serial and part numbers. The cybernetic scheme has a note showing the PSU's manufacturer and part analysis, so cheating isn't as easy. Externally, both GF80 versions look the same and have the same dimensions, but there are some notable differences. The position of the power switch, the position of the screws holding the top cover in place, the modular board. The power specs labels on both units differ. However, the 80+ logo is present in both. The part number and model numbers are different. The modular panel has some hidden sockets in the CE Link version. The cables are the same between these two units. There are enough connectors, but using two EPS connectors on the same cable with standard 18 AWG gauges can be dangerous. These connectors should be installed on dedicated cables because they can deliver more power than 6+2 PCI Express pin ones. They use 4 total power pins instead of the 3 that the PCI 6+2 pin connectors use. Cable length is sufficient, although it would be better if the EPS cables were a bit longer, reaching or ideally exceeding 700 mm. Lastly, the distance between all peripheral connectors is ideal at 150 mm. While the HKC version uses a higher quality double-sided PCB, this one uses a plain single-sided PCB, usually found in low-cost PSUs. The FETs are also of lower quality. The CE Link version uses a single bulk cap, while the HKC version uses 2 Rubicon ones with lower combined capacity but of notably higher quality. The ePFC and resonant controllers are the same, and the same applies to the controllers that handle the minor rails. The primary topology and the design of the secondary side are also the same. The CE Link version uses more electrolytic caps of decent quality and has 3 fewer polymer caps than the HKC version. Moreover, the supervisor IC is different. A major difference is the cooling fan, which uses a true fluid dynamic bearing in the CE Link version, while a plain sleeve or rifle bearing is used in the HKC version. Lastly, there are also differences in the 5SB circuit as expected. The CE Link unit has a lower quality PCB, which matters a lot in terms of performance, and its FETs are from a less known manufacturer. The filtering caps on the secondary side are slightly higher quality, while its fan is notably better than the one used in the Chinese model. Overall, the HKC unit's design is superior, allowing for better airflow, especially on the secondary side. The OCP triggering points are sky high, and to add injury to insult, the normal and hard OCP points are similar. To make matters even worse, the overpower protection's triggering point is notably higher at high temperatures, while it should be the other way around. The PSU is stressed more at high operating temperatures, so it is only natural to tune the triggering points to lower settings. Another major issue we faced with the first sample is that it died during the short circuit evaluation between 3.3 volt and earth. We had the second sample which passed this test. However, we cannot be sure if everything is okay with such a small sample pool. Surely, the fact that the first one died during short circuit protection 3.3 volt evaluation is not a good sign. Load regulation is about the same between both versions. It is not that tight in general. The C-Link unit achieves better ripple suppression at 12 volt but loses notably at 5 volt and 5 VSB. The transient response with normal loads is mediocre. The PSU passes all ATX version 3.1 transient response tests. The 12 volt rail performs well in the 200% load test, with the difference between the two versions being small. Efficiency is high at normal loads and light loads, but none of the GF A3 versions passes the recommended by the Intel spec 70% threshold with a super light load. The unit's average efficiency is high. The HKC model has a lead here. The PSU converter needs tuning in both units to deliver higher power factors, especially at 230 volt. The 5SB rail should be more efficient at 230 volt. Vampire power is low at 115 volt but above 0.1 watt at 230 volt. The average noise is low. The PSU's average noise output is notably lower than the HKC models, but it is also better to look at the noise maps. The semi-passive mode lasts long enough, but there are areas within this operation region where the fan speed goes wild. This can be very annoying as the fan starts up and spins at high speeds for a short period to remove the heat. The 30 decibels mark is passed at around 545 watt and the PSU's noise exceeds 35 decibels at 635 watt at 12 volt. At 230 volt, the fan's wild operation at light loads lasts longer. The 30 decibels mark is passed at 520 watt and noise goes over 35 decibels once the load at 12 volt exceeds 600 watt. The overall performance is low. It is not that the HKC version was a top performer, but the C-Link version is even lower. It is not the best thing to have a PSU line and silently replace it with a platform of another OEM. The honest way to do that is to change the series name. Thermaltake uses the 80 plus badge on this PSU to make matters worse, while the HKC version is certified and not the C-Link model. This is false advertisement, to say the least. It is very easy to fool the 80 plus system, and Thermaltake took advantage of it since it didn't want to pay the high fee to recertify this unit. However, this is wrong in any case, and future buyers of the GF A3 750 CE-Link version should know that. Some low-end brands use fake certification badges, but I didn't expect this from a large brand. In the protection features section, although the first sample survived heavy abuse during the overcurrent and overpower protection features evaluations, I even tried below 100 volt input at 45 degrees Celsius. Still, it died in the plain short circuit evaluation in the 3.3 volt sorted with earth test. Since I had the second sample, I tried that specific test again without any issues this time. Given the limited samples that I tried though, I cannot be sure whether the protection features on this unit operate normally or if there is a problem. I need a larger sample pool to find out. In any case, having one of the two samples dying is worrisome. The Thermaltake Tough Power GF-AT750 is priced decently for the category's standards. It passes all ATX version 3.1 tests, but given the fake certification badge and the messy protection feature settings, I would stay away from it. Moreover, its overall performance is low and the fan spinning at high speeds for short periods at light loads will annoy most users. It is better to disable the fan's passive operation in this model. Before investing in a new power supply, read my best ATX version 3.x PSU's article on hwbusters.com to check all alternative PSU offerings. You will also find this product's review on the same site. That's all. Bye bye.